Okay, Longhorns, here's the test 4.2 review, and we're going to start with this table right here. We're going to complete the table. Some things that you want to keep in mind during the test is when you're looking at your equation, y equals negative sine 1/4 theta minus pi minus 1, that each one of those numbers has a purpose in our table and in our graph. So very quickly, let's take a look at what these are. This 2 right here, this -2, is our A value, or our stretch or compression, and vertical stretch or compression. Now the 2 part, not the negative sign, but just the 2 part would be the amplitude. The next number we're going to look at is the 1/4. This 1/4 is our value for B. That's going to be our horizontal stretch or compression. Now this value right here, this minus pi value, that is actually our C divided by B. Since we've already factored out B, then that's going to be the phase shift. And then this last number right here is D, and that's our vertical shift up or down. Okay, so what affects what? Well, the inside, right here, the B and the phase shift affect theta. So on your chart, when you get ready to fill it in, those are the 2 values that you need to look at when you're filling in your table. So first of all, with theta, with the insiders, we do the opposite operation. So if we have 1/4, that means that we are going to multiply theta by 4. So we're going to multiply first, and then we're going to do the opposite operation here with our phase shift. With this says minus pi, so we're going to add pi. Okay, so let's do all those theta changes first, and then we'll look at the sine of theta. All right, so 0 times 4 is 0. Pi over 2 times 4 is 2 pi. Pi times 4 is 4 pi. 3 pi over 2 times 4 is 6 pi, 6 pi. And then 2 pi times 4 is 8 pi. All right, so when we get to this last change right here from B, this right here is actually going to be our period. So our period for the new graph is going to be 8 pi. All right, in addition to that, we also have a phase shift of plus pi. So we're going to go through and we're going to add a pi to all of the angles that we already have. So 0 plus pi is pi. Then we're going to have a 3 pi, 5 pi, 7 pi, and 9 pi. All right, so that's all the changes we have to our angle. Now we need to look at the changes to the function. Here we have a sine function, and we've already listed the values for sine of theta. And so now we need to take a look at what changes the sine function. This number right here is going to be our vertical stretch or compression. This number right here is going to be our vertical shift. So those are the 2 things that are going to affect the function. First, we need to multiply. So we're going to multiply by -2 first. And then we're going to subtract 1. So we take all of our numbers for sine. We're going to multiply by -2. So we get 0, -2, 0, 2, and 0. And then we're going to subtract 1 from them. So -1, -3, -1, 1, and -1. All right, so what do we graph? This is the big question. What do we graph? We're going to graph the last change we made to our angle, which is going to be what we're scaling along the horizontal axis. And we're going to graph the last change we made to the function, which is what we were going to graph along the vertical axis. All right, so in other words, this would be the same thing as x, and this would be, and I'm going to put it in quotes because it's not really x, and this is y. but not really y. But if you want to think of it as graphing on a coordinate plane, you can think of it as that. So these last angle measurements are all of our x values, or the horizontal values, and then the last measurements for the sine of theta are the y values, or the vertical values. So let's go ahead and take a look at our graph. Now we're going to graph it. So I'm going to move this graph up so you can see a little bit better. All right, so one of the things that you might have to do, and I'm going to do it on this graph, is I'm going to go ahead and change the scale, because the scale on this graph goes to 2 pi, and that's not quite adequate. I'm not going to be able to fit my whole period on this graph. So what I'm going to do is I'm going to go in here and I'm going to change the angle measurements for the scaling on this graph. So I'm going to start at 0, and I'm just going to stick to the right side of my graph. And I'm going to change these to, in terms of, each one of these units would be a pi. That way at least I can get a full period on here. And I'm going to add one on the end down here for my 9 pi. So I have pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, and 9 pi. Oops. Okay, so those are going to be my quote-unquote x values, and now my y values are going to be the -1, -3, -1, 1, and -1. So I'm going to go through here, and I'm going to go to the first one, which is pi, and I'm going to graph pi -1. Okay, so that would be down here, pi -1. And then I'm going to graph 3 pi -3. 3 pi -3 is going to be down here. Then 5 pi -1, back to -1 again. Then 7 pi is going to be 1, so we're going to jump up here. And then 9 pi, which is my last angle, I'm back at -1 again. So you see how it forms this pattern, or this wave. So then you just draw in your wave. Okay, just like that. All right, and that's it for the graphing. Now, down here at the bottom where it says period and all that, all of this information you can get right from your equation, okay? So I'm going to go ahead and bring this up a little bit so you can see better. All right, so the period we said was 8 pi. That's how long it takes to complete one cycle. 8 pi. The value for B is 1/4, comes right off your equation. Keep it simple. You don't need any formulas or anything, just look at your equation. Amplitude is going to be 2. Remember, we need to keep amplitude positive. Vertical slide, remember, was a -1. We went down 1 unit. And the phase shift was plus pi. Important to keep the sign right here, because the sign changes, depends if it's positive or negative. If it's negative in your equation, it's going to be positive phase shift. If it's a positive in your equation, it's going to be a negative phase shift. So you need to make sure that that sign is on your test and it's the correct sign. Okay, so let's move on to the other side of our paper. Okay, question number 2. You lean a ladder that is 12 feet long against a wall. It makes an angle of 46 degrees with the level ground. How high up is the top of the ladder? All right, so on your test, you actually are going to get a triangle already inserted for you. So all you need to do is label it. So we're going to label our sides and our angle. So our ladder is 12 feet long. We can call that the hypotenuse, because this is the part that's leaning. Okay, this side over here is our length of our wall, and we want to know how high that is, and this angle right here is 46 degrees. All right, so we have a hypotenuse, we have a side opposite, and then we have a side adjacent. Well, we don't have any information for the side adjacent, so we're going to use the opposite side and the hypotenuse. Well, if I'm going to be using an opposite side and a hypotenuse, I'm going to use sine. So sine of 46 degrees equals, and then I put in my ratio, opposite, which is x, over hypotenuse, which is 12. All right, now to solve for x, all I need to do is multiply both sides by 12. So I'm going to multiply my sine 46 degrees by 12. 12 sine 46 degrees. Now when you put this in your calculator, don't forget to put your degree symbol in, otherwise you're going to get some weird number. So when I put that in the calculator, I get 8.63 feet. All right, in the next problem, in order to reach the top of the hill, which is 145 feet high, you must travel 1,200 feet straight up a road which leads to the top. So again, on this one, we've given you a triangle. It's already going to be on the test. All you have to do is label it. All right, so the hill is 145 feet high. The road is 1,200 feet long. And the angle that it creates is with the ground, horizontal with the ground. So we don't know what theta is, so we've got to solve for theta. Okay, so again, we label our triangle. We have a side opposite, we have a hypotenuse, and we have a side adjacent. Well, again, we have a side opposite and a side hypotenuse. So again, we're going to use sine. However, we're looking for the angle. So whenever you're looking for an angle, you're going to use the inverse sine or arc sine. Okay, in your calculator, that's going to look like this. Sine with a little -1 at the top. That little -1 at the top means inverse. Okay, so sine inverse or arc sine, and we're going to go ahead and put in our ratio, arc sine of 145 over 1,200. And what the calculator is going to give us, since our calculators are in radian mode, the calculators are going to give us this angle measurement in radians. So let's go ahead and put that in the calculator and see what we get. Okay, so that gives us 0.12 radians. Okay, so make sure when you answer this question that you know that this particular angle measurement is in radians and that it's 0.12. It's not degrees. Please do not put a degree symbol at the top of that 0.12 because it does not degrees. Those are two different kinds of measurements for angles. This one, the calculator is giving you in radians. All right, the next problem we're going to do is number 4, and this is a unit circle problem. All you have to do for number 4 is look at your unit circle that's on your formula chart that you've been given. Look to see where sine is √2/2, and you're going to see that it's √2/2 at pi/4. Okay, and you also have to remember the restriction on sine inverse. Sine inverse is only going to be given between -pi/2 and pi/2. So the answer we're looking for is pi/4. All right, so the next problem, number 5, we have arc cosine and then cosine and an angle measurement. And so basically all we're testing here is to see if you understand that the arc sine and the cosine undo each other. So the arc cosine and the cosine undo each other, and then what we're left with is pi/3. It's just that easy. Okay, number 6. All right, so for number 6, we're solving for theta. So the first thing we're going to do is add 3 to both sides of our equation. We get 3 sine theta equals 3. Then we're going to divide by 3, and we get sine theta equals 1. And again, you can look on your unit circle to see where the sine of theta equals 1, and you're going to see that that occurs at pi/2. And that's your answer for theta. Number 7, again, we're going to divide by 3. And that gives us tangent of theta is negative 3 root 3 over 3. Well, we can cross out some of these 3's, and we're left with tangent of theta equals negative square root 3. And I'm going to look on my unit circle with restrictions to tangent inverse to see where tangent is negative root 3, and that's going to occur in quadrant 4 at 5 pi over 3. Pi over 3. All right. The next problem, problem number 8. This one requires you to draw another right triangle. Right here we have an angle measurement, and we want to know what the sine is of that angle. Well, we don't know what the angle is, but we know that the tangent of that angle is 5 over 12. So I can draw a triangle, and I can label the sides. The opposite side of the angle is 5, and the adjacent side of the angle is 12, because tangent is opposite over adjacent. So opposite over adjacent, and then I use the Pythagorean theorem to solve for the hypotenuse, and I get 13. All right, so I need the sine of that angle. Well, sine is opposite over hypotenuse, so 5 over 13. And that's it. All right, number 9. So here we're solving again. This time you're given the triangle, and then you're just solving for what the missing variable. In this case, we're solving for x for number 9. And we would use, since this is our angle right here, this is a side opposite, this is a side adjacent, this is the hypotenuse. I have an opposite over adjacent, that's going to be tangent. So tangent of 24 degrees equals x over 12. And now I'm going to put that in my calculator and see what that is. That's going to be 12 tangent, 12 times tangent of 24 degrees. What does that equal? All right, so we get x equals 5.34. Okay. Number 10. In this case, we're looking for an angle. So I've told you before, when we're looking for an angle, we're not going to use sine, cosine, or tangent. We're going to use the inverse. Okay, so we have to use the inverse to find the angle. So we're going to use arc sine, arc cosine, or arc tangent, depending on what values we have. Well, we've been given a side opposite, and we've been given a side adjacent. So guess what? We get to use arc tangent. So I'm going to write that in right here, and I'm going to put it in my calculator. Arc tangent, and then I put in my ratio, 9 over 21, equals, and then I'm going to find out what my theta is. Let's see. Okay, so we get 0.40 radians. All right, so remember that when we're getting the angle measurement out of our calculators are in radian mode. So the answer we're going to get is in radians, and just leave it in radians. Don't convert it to degrees, just leave it in radians. That's fine. That's all we need for now. All right, next question is number 11. So in number 11 and 12, we are verifying what's on the left of the equal sign is the same thing that's on the right of the equal sign. So one of the tricks that I told you to use, which is very helpful, is to go ahead and change all of your functions into terms of sine and cosine. So if I look at my formula chart under cotangent and tangent identities, I see that cotangent is cosine over sine. So I'm going to write cotangent as cosine over sine. And also looking at my identities, I see that secant of x is the same thing as 1 over cosine of x. All right, so here I can cross out my cosines, and I'm left with 1 over sine of x. And if I look at my identities, I see that 1 over sine x does in fact equal cosecant of x. And voila, verified. All right, next problem, number 12, same concept. We are verifying that secant of x minus tangent x times sine x is the same thing as cosine x. Now this one has a few more steps to it, but it's basically the same thing. We're going to convert secant of x to 1 over cosine. And we're going to change tangent of x to sine over cosine. And then we still have times sine. All right, so when I simplify this, I get 1 minus sine squared x. Now by now, if you've been practicing, you will recognize that 1 minus sine squared x is one of our identities. So remember, anytime you see a sine squared or a cosine squared with a 1, or cotangent squared with a 1, or secant squared, then you might have an identity. So go ahead and check your formula chart to see if you have an identity. Well, 1 minus sine squared x is one of our identities. It's cosine squared x. So 1 minus sine x is cosine squared, and cosine squared x over cosine x. Now I get to simplify that one more time. So I can cancel out one of my cosine x. Okay, so that's it. We proved that secant x minus tangent x times sine x is cosine x. All right, in the next problem, in number 13, you have to write a paragraph, okay? And you have to discuss what steps you took to verify the trigonometric equation in number 12. Make sure that you use complete sentences and proper grammar and proper spelling and everything for this writing prompt. All right, then we have a bonus question, 5 points bonus question. And this one is solving for x. This is a two-step problem or multi-step problem. I'm going to give you one hint here. I'm not going to give you the answer, but I'm going to give you one hint. You can solve for the middle line first using these values, the 39 degrees and the third side 38, and then use that value, the y value that you get, to solve for x. And that's it. Good luck on your test.